Good evening. I'm Mike Knetter, and welcome to the UW Now, where we bring you experts from the Badger community talking about timely and important topics. Tonight, we've got something kind of special. We're going to have our first ever guest host, Tom Erickson. And you might wonder, well, why are we having a guest host? Well, tonight's topic is artificial intelligence. What would I know about that? Take that however you want. But it's great to have Tom on the show. And so, I'm going to introduce Tom and then hand it off to him, and he's going to introduce our experts this evening and moderate our discussion. Tom is a renowned computer science expert who currently serves as the director of the School of Computer, Data, and Information Sciences at UW-Madison. And I will say that is one of the most exciting developments on campus in decades. Tom has over 3 decades of experience himself in the tech industry and recognized for his exceptional skill in designing and managing complex software systems, including user-centered design and software engineering. In his current position at UW, he's responsible for the development and execution of the school's strategic vision, including fostering inclusive and equitable academic community, dedicated to advancing innovative research and education in computer science and related fields. Tom is a graduate of UW-Madison in electrical engineering. He is also a proud graduate of Mondovi High School, and I will add a very generous donor to the mission of CDIS at UW. Joining Tom tonight will be 3 of UW-Madison's artificial intelligence experts who will guide us in a conversation as we sort out fact from fiction in the growing field of artificial intelligence. Tom, thank you for being here tonight. Pleasure to have you as our first guest host. And I'm going to get out of the way and learn about artificial intelligence from you and our panel of experts.
Well, thank you very much, Mike. It's a real pleasure, and I'm honored to be the first guest host. A little fact for everyone or that you may not know is Mike revealed to me beforehand that introduction that he read, which may have been a little bit artificial because it was written by ChatGPT. And Mike got that idea because I wrote my introduction also using ChatGPT, and we'll talk a little bit more about that later. So before I get into that, though, I'd like to just mention that we have a very rich heritage of computer science at the University of Wisconsin-Madison. It, in fact, was the second computer science department in the country. Founded in the 1960s, Purdue has the status of the very first. So we had the second, but we did graduate the country's first PhD in computer science in 1965. A woman, actually, a female by the name of Sister Mary Kenneth Keller. So she was a nun, and she was a foremost leader in the country in computer science. And we're very privileged to have that history, that rich history. So tonight, we're going to talk, I asked ChatGPT, which I encourage all of you to go out and try. It's free to try. I asked it a question, and this is how you work with it. I said, please write an introduction to a webinar entitled Artificial Intelligence, Fact or Fiction, with a panel consisting of 3 luminaries from the University of Wisconsin-Madison. And this is what ChatGPT has to say. Welcome to our webinar entitled Artificial Intelligence, Fact or Fiction, featuring 3 distinguished panelists from the University of Wisconsin-Madison. Our experts, Dr. Jignesh Patel, Professor of Computer Science, Dr. Sharon Li, Assistant Professor of Computer Science, and Blaine Hoak, a PhD student in computer science, who will provide insights into the world of artificial intelligence. AI is a rapidly evolving field that has seen immense growth and development in recent years. It is changing the way we live and work and has the potential to revolutionize many industries. However, with this rapid growth, there are also questions and concerns about the impact of AI on society, ethics, and the role of humans in the workforce. Our panelists will explore these issues and more, discussing the current state of AI, its potential future, and the challenges and opportunities it presents. They will also explore some of the myths and misconceptions surrounding AI, separating fact from fiction. We look forward to an insightful and informative discussion that will help us understand the impact of AI on our lives and the world around us. So I welcome my three distinguished panelists. Very good. Welcome, one and all. It's exciting to have you all here. Tonight, I have the privilege of introducing each of you. We're going to start with Sharon. We're going to have a first chance to go. And so I welcome you. Sharon Li is an assistant professor, or Dr. Sharon Li is assistant professor in the Department of Computer Sciences. Her research areas are in the an area called deep learning, which I won't go into in a lot of detail, Sharon. Maybe you will talk a little bit about that, but it deals with how neural networks in the brain are modeled in computers. Specifically, Sharon works with understanding and design sophisticated attacks that allow people to evaluate the trustworthiness of machine learning on systems we use today. Recently, I made a mistake there. I take that back. Sharon develops algorithms and fundamental understandings to enable reliable open world learning, which can function safely and adaptively in the presence of evolving and unpredictable data streams. Sorry about missing that up earlier. So
no worries.
Prior to coming to UW-Madison, Dr. Li was a postdoc researcher at Stanford University, and she's a recipient of Forbes 30 Under 30 Science Award. So it's a real pleasure to have you, Sharon, and take it away.
Thank you, Tom, for the very kind introduction. Really excited to be here at the UW Now show. Thank you for inviting me and for having me here. In this presentation tonight, I would like to share some of the biggest challenges that we face in AI today, which is how to make AI safe and reliable for the open world. I would like to start this presentation by showing you this video. This is a model trained on the Berkeley Deep Drive 100K dataset, performing bounding box tracking as the car drives on the road. So these colorful boxes you see here highlights the objects such as cars and traffic light that we care about when driving on the road. And whenever we see cool demos like this, it's very easy to get overly positive impression of how remarkable artificial intelligence has evolved to be. And this is true in a lot of scenarios and applications. However, in my research, I encourage researchers and practitioners to look at the other side as well, especially be aware and pay attention to the unexpected situations that the model wasn't trained for. So what do I mean by that? Now I would like to invite the audience to have some role playing here. Imagine you're the head of AI at this company called Tesla. Now think about how you would approach building and deploying such a self-driving car model. If we abstract this entire process, we typically start with gathering some training data, where each of these photos of cars are individually labeled. And then we would train on our favorite machine learning model, say in this case, a neural network. Here, this output would typically contain some predefined categories, in this case, pedestrian, cars, and truck, and so on. And let's say once you've navigated through all these challenges and finally have a model with a reasonable performance that you think it's ready to roll out in the real world and be deployed, this is where a lot of unexpected trouble would start to happen. And why do I say that? Because the classic machine learning assumption that we've made for decades is that the training, what the model was trained on, versus what the model would see in the future, these two types of data match each other. However, this assumption rarely holds true in this what we call open world, where the training and testing data distributions can be wildly different, and lots of unknowns could emerge. To give you a concrete example, in our recent research, my student, Shifeng, if you could navigate to the next slide, please. My student, Shifeng, took this image from the MS-CoCo dataset and run through the self-driving car model we just trained on BDD dataset. So you can see that the model would produce an overconfident prediction for this unknown object helicopter right in the middle. And keep in mind that this helicopter was never exposed to the model during training time. So in other words, deep neural networks do not necessarily know what they don't know. And this has caused significant concerns on models' reliability and safety. And to give you a concrete example in real life, I'm quoting this news article and actually a video which showed that a Tesla vehicle crashed into a private jet. And so if we look at this video, you could see this car is driving right towards this private jet here. Unfortunately, no one got injured in this incident, but you can imagine the gravity of this issue, of this, when incident like this happens. And so obviously this problem of AI safety has become very, very important and has been gaining increasing attention in research community over the years. Next slides, please. And so ideally, we would like to identify these unknowns, or what we call out of distribution data. So this way, the AI models not only predicts what they know, but also being able to flag what they don't know, such as on the right-hand side of this image. And this problem of out of distribution detection is close to my heart and is something that I have been having lots of fun working with over in the last couple of years. Next slide, please. And so to distill down what I'm trying to say, this slide from OpenAI nicely illustrates the complexity and necessity of this problem. So the left-hand side is what machine learning has been focusing on in the last few decades, where the model is typically trained on a task-specific data set. And in contrast, the right-hand side is this complicated data manifold that we would encounter in the real world. And this could contain all the possible images that one could possibly generate and encounter on the internet. And so open world machine learning is really about pushing the frontier from the left to the right-hand side. Next slide, please. To summarize, the goal of my work is to build next generation machine learning for reliable and adaptive decision-making in this realistic open worlds. And lots of what we do involves innovating in algorithm development, deriving theoretical understanding, and ultimately launching those into real world. I would like to conclude my talk and presentation by also highlighting the broader spectrum of AI activities here at UW-Madison. I'm really proud to be embedded in this larger AI research ecosystem here, which has been driving both fundamental and applied research innovations. And so this slide really highlights a large group of faculty members from both CS department and other affiliated members from stats, ECE, and so on. And if you're interested in learning more about machine learning research activities at UW-Madison, I highly encourage you to check out this website, machinelearning.wisc.edu, which showcases, the people and the research we do here and the education courses that we offer. Thank you, and I look forward to the presentations from Blaine and Jignesh and the fun discussions we'll be having tonight with all of us.
Thank you very much, Sharon, and thank you for joining us so far away. So we appreciate that. It's fascinating stuff. We're so excited to have you as a part of our team. So I'm excited to introduce Blaine Hoak, who I just have had the chance to meet. Welcome, Blaine. Blaine is a PhD candidate in 2025. We hope that'll happen. Very fortuitous year. So as a PhD student in computer science, she's focused on researching adversarial machine learning. Say that 3 times very quickly. Specifically understanding and designing sophisticated attacks that allow people to evaluate the trustworthiness of machine learning systems we use today. And in case you can hear Derek in the background, Derek is very excited to hear what you have to say tonight, Blaine. Recently, and this is a passion area of mine, Blaine, you probably didn't know that, you've become interested in computational neuroscience. It's a fascinating area that I think is going to change much of the way we think about a lot of things in the world, and developing biologically plausible models with security in mind. And there's lots to be thinking about. Blaine has an undergraduate degree in biomedical engineering from Penn State University, and we're pleased to call her our own now. So over to you, Blaine.
Thank you so much for the really kind introduction. Hi, everyone. It is an honor and a pleasure to be here with you all. Tonight, I am very excited to talk to you about trust, expectations, and failures in AI systems. Next slide, please. So when I was planning out this talk, I originally wanted to start with some profound statement on how the world feels about AI. That proved to be incredibly difficult because people feel very differently about AI. But I did find this cool survey from Pew Research that looked at what makes Americans more concerned or excited about the increased presence of AI in daily life. Interestingly, many of these results seem to contradict each other. People don't trust AI, but they think it'll make life better. AI isn't like humans, but it's more accurate than humans. AI can fail, but those failures aren't really rooted in reality or may actually come from our own human biases. Beyond this, I think a lot of people also aren't really sure how to feel about AI because it's moving so fast and there's so much information out there, and also a lot of really unsettling stories. Some people, despite any excitement they may have about AI, might also just be afraid of AI without even really knowing why or what it is exactly that they're afraid of AI systems doing. Next slide, please. So I think it's safe to say that this is a confusing time for many people. So tonight I wanted to briefly talk about some of the concrete ways that AI fails, what it means to have trustworthy AI, and the role that we as a society and as experts of all of our own areas play in all of this. Next slide. Thank you. My research focuses on evaluating and advancing the security of AI systems. I can tell you firsthand that AI systems do fail, and these failures are real. Sometimes these failures can be at least a little bit understandable in the sense that we know it's a mistake, but we can pretty quickly tell why the mistake was made. So the left-hand side here shows pictures that were fed into an AI image classification system. The system then outputs the percent confidence in this object belonging to different classes on the right side. So on the top, we see a Granny Smith apple that is originally correctly classified as such. However, if we stick a note on the apple that says iPod, it now gets classified as an iPod and very confidently classified as such. Even though we know that this is a mistake and this apple with a note on it is not an iPod, we have a pretty good idea of what made the AI system classify the apple this way. So this failure, while it is still a failure, isn't necessarily unexpected. Next slide, please. In some ways, we even fall for similar things. For those not familiar with this painting, the translation for the French in this artwork is, "This is not a pipe." This is because this is not a pipe, but rather a picture of a pipe, or I guess now a slide of a picture of a pipe. Next slide, please. Sometimes AI fails in ways that we don't expect either, though, and this can be incredibly dangerous. Back in 2019, a woman pushing a bicycle across a 4-lane highway was struck and killed by a self-driving vehicle. The car did not brake in time because it didn't recognize her as a pedestrian. It thought that she was maybe a bike or a car, so it estimated her path incorrectly. The person in the driver's seat was also watching TV, so she wasn't able to react in time to take over. After the accident, upon further inspection into why the car didn't recognize the pedestrian, it was found that the AI system that was used to classify objects in the self-driving car had only been trained on images of pedestrians and crosswalks. So it learned that in order to be a pedestrian, you had to be in a crosswalk. These are the kinds of failures that we don't expect, the kinds of mistakes that we as humans would never have made. We have this tendency as people to see the great successes of AI systems and feel like we're witnessing something that's human-like or even superhuman-like. However, AI systems are something else entirely. They don't learn the way that we learn. We know that a pedestrian is just a person walking and has nothing to do with the crosswalk. Classifying something like pedestrians feels easy and obvious to us, and sometimes we make the mistake of thinking that this means it should be easy and obvious to an AI system as well, but it isn't. Next slide, please. So all failures affect the trustworthiness of AI systems, but especially the failures that we don't expect, because they're often harder to catch and we don't see them coming. Over the years, researchers have identified many different failures, studied their causes and impacts, and even defined some necessary qualities for AI systems to have, all to try to quantify what it really means to have trustworthy AI systems and to build the field that we call trustworthy AI. As a result, understanding ways that understanding ways that AI systems are not trustworthy and building AI systems that are trustworthy spans many different sub-areas. For example, we need security to ensure that AI systems can't be attacked by bad actors supplying malicious inputs. These inputs, called adversarial examples, are especially designed to cause a mismatch between human perception and AI output. Adversarial examples can be created to do things like bypass facial recognition systems or make a self-driving car think that a stop sign is actually a speed limit sign. We also need to make sure that AI systems don't leak private data, especially in the case of private medical data where we have regulations like HIPAA. We also need them to be free of biases, like the one that only classified pedestrians that were in crosswalks. We need to be extra vigilant about biases that result in unfair treatment of different groups of people too. For example, facial recognition systems have been shown to be less accurate on women and people of color. We also need these systems to be robust, meaning that they need to be accurate and generalized to inputs that were different than what they were trained on, like still being able to see a stop sign even when it's snowing outside. We need these systems to be safe for the public to use and not cause harm to greater society. We also need to build systems that are explainable, meaning that they can provide reasoning for their choices. Like instead of having an AI system output, this is a dog, maybe we should have it output, this is a dog because it has floppy ears, or something like that. Finally, we also need AI systems to be interpretable, meaning that we can easily see the series of decisions that are made and understand what sorts of relationships are being learned by the AI system as it works to classify things. Next slide, please. So a lot of what I just talked about are core research areas for AI researchers, but so much more goes into actually making trustworthy AI happen. And this is not just an AI researcher's problem. The self-driving car in the previous example should have been better tested to ensure that it didn't exhibit the biases that it did. And there should have been stricter regulations to enforce this testing. So we desperately need policymakers to help create and enforce rules and regulations around AI to ensure that these systems are thoroughly tested for vulnerabilities before they have a chance to cause harm. In many cases, the problem also starts before we even bring AI into the picture. We need people who specialize in collecting and analyzing data to help us understand when we have biased, unfair, or otherwise bad data that we shouldn't be throwing AI at in the first place, because AI systems can only be as good as the data they were trained on. As I mentioned earlier, AI systems do not learn the same way humans do. However, if we want AI systems to more closely resemble the way that we learn, we need psychologists and neuroscientists and computational neuroscience to help us understand how humans make decisions, how the human brain works, and to help drive cross-disciplinary research. As these technologies are being adopted into our society, we also need educators and teachers to inform the next generation of people who are going to be working towards a future that will be even more strongly integrated with AI systems. Finally, we, as a society, get to decide what trustworthy AI means to us. We get to decide what we should be able to expect from AI systems. Next slide, please. As a final note, I think it's important to mention that while we may not have fully trustworthy AI yet, That doesn't necessarily mean that we can't or shouldn't use AI for anything, or that we need to be afraid of it. Like everything else in life, there are risks. Staying informed and setting our expectations for the capabilities of these systems accordingly is a key part of interacting with them. And as a closing, I'll just say AI is moving quickly, but it's not moving without all of us. Thank you so much for listening, and I'm looking forward to answering any questions you have.
Wow, thank you, Blaine. I definitely feel better in this world knowing that you're out there helping us to make sure that AI is trustworthy. Thank you very much.
Thank you.
We'll bring you back in a moment. And as Jignesh comes online, I want to take just a moment and introduce CDIS as well. Jignesh, maybe you can join me in that. Professor Patel. CDIS is the newest school on the UW-Madison campus. We're a little over 3 years old, actually. We'll be 4 in August. And we've grown very quickly. When I joined to start the school, we were just a little over 3,000 students. Today, we have just under 5,000 students. So we're growing at a very fast clip. We have both the largest major on campus, computer science, which is 2,200 students, and the next nearest major is around 1,400. So it's much bigger than the other majors. CDIS also has the fastest growing major. Just over 3 years old, our data science major has 1,200 majors already, adding hundreds per year. Interesting thing about both these majors, and something that's unique and very special about the University of Wisconsin-Madison, is that the students that are taking these majors are many of them are double majoring. So in computer sciences, for example, 40% of our students are double majors, and they come from 78 different disciplines. So the way we've structured computer science, it means you can take philosophy and computer science or botany and computer science, and you can become a computational botanist very easily, even with your undergraduate studies. And I want to credit Jignesh and the faculty we have at Wisconsin for doing two things. First of all, creating that kind of program where we can have double majors and allow so many people get access to these really important classes where they can also, use that learning to get great jobs. But another big thing that's special about us is that we do not cap our enrollments at Madison, something that our peers, especially in California, Washington, Michigan, do. And that means if you're able to get into UW-Madison, which is getting increasingly more difficult, you can actually, study computer science if you wish. And that was certainly Jignesh's desire. Jignesh is one of our proud graduates as well, as am I. And with that, Jignesh, I'll introduce you. So a professor of CS at Wisconsin, his research group is dedicated to developing more efficient methods to generate insights from data. So I think of Jignesh as the data guy. His work focuses on improving both systems efficiency and human efficiency, which is something else I'll introduce. At CDIS, we have a saying that we are technology at the intersection of humanity or society. And you've heard it both with both of our earlier speakers, and you'll hear it again from Jignesh now. It's with the past has been about making faster computers and better software. The future is about how does this impact us in society and how will we improve it? And Jignesh's work is about that. Jignesh is the author of dozens of publications, and near and dear to my heart, he's a serial entrepreneur. His latest company, DataChat, you'll get an overview of. It's really one of a very successful company coming out of the university. But he doesn't rest on those laurels. He's also the founder and organizer of the premier entrepreneurship competition on campus called CS Nest. And he is, in fact, also on the entrepreneurship committee of the Wisconsin Economic Development Corporation. So a man very committed. Thank you, Jignesh, for joining us, and over to you.
Thank you, Tom. And thank you, Tom, for all that you've done for computer science, and all looking forward to that exciting new building. Thank you, everyone, for joining us. I'm going to talk about 3 things in the 6 minutes or so that I have. So if you could bring the slides up, please. So the first part, I know already from many of the comments that there's a lot of fear about where is this AI going. And I want to ground us by very briefly in 2 minutes doing a very quick history of how did we get here. What we see in ChatGPT and all kinds of AI technologies like the vision technology that Sharon mentioned is a confluence of three forces in computer science that have come together very, very quickly over the last decade. So the first piece of the puzzle is data. And many of you must have heard of big data that started towards the start of this century. And that was driven by the fact that we now have the ability to collect data, which was an articulation of physical word signals, converting that into a digital form, and we could store it cheaply and economically. That data that we kept collecting over the time, whether it's in the form of the internet or in the form of genomic sequencing that we collected, is the foundation for a lot of the things that started to make this AI stuff happen. I'll tell you how in a little bit. Next slide, please. The second big component, and this is stuff that's been going on for centuries, are these mathematical algorithms. And here, literally, you're seeing a visualization of a neural network, the type that Sharon works on, that's basically learning how to separate the yellow and the blue regions from. But the math for many of these things are centuries old. But there were some breakthroughs that started to happen just towards the tail end of last century and really accelerated over the last decade or so. Next slide, please. The third piece that has brought us to where we are is compute. And this has been happening since the birth of computer science, which, as Tom mentioned, is a very new field compared to all the other sciences. It's, even if you are very generous in seeing, in starting the clock for when computer science began, it's no more than 70 years old and probably closer to 60 when we really got going. What you see at the top over there with that blue and yellow stripes is a Cray computer that was built up in Chippewa Falls in Wisconsin. And in 1982, that was amongst the fastest computers on the planet. In fact, one of those was sitting in the computer science building when I was getting my PhD over here in the 90s. That could compute things, and that was the fastest machine. Today, your iPhone is when you compare how much compute you can do in your iPhones and how cheap it is, it's about 37 million times cheaper. And that tremendous power is what's allowed to have the AI algorithms work on the data with this quote unquote cheap compute and make AI happen. Next slide, please. And so the confluence of these three things, the data stuff, algorithms, and cheap compute, next slide, is what really, next slide, is where we are. That little yellow dot is what we are excited about. And I know a bunch of questions have been asked. Steve has been asking about how is this AI stuff different than humans? It is being fed with data that we've been collecting all along from the internet and other sources, question and answering sources like Quora. So today, what you're seeing with all the generative AI stuff is data being fed that we've been able to collect over decades now, and we're feeding into these algorithms, getting powered by this cheap compute. It still costs tens of millions of dollars, as Christian just asked a little while back. So it's not for the meek. You have to have a ton of money to train one of these algorithms that you can then deploy. Next slide, please. And we'll have a deeper discussion on all of that. Just a one quick minute stuff about what DataChat is. It's a spin out from my lab where we are trying to make, next slide, we are trying to make data science, which is the art and science of being able to get non-trivial insights from data and make that available to anyone. So we want to democratize data science, which today you can carry out these types of deep insights from data, but you have to be a 5-star programmer in one of the data science languages like Python or SQL or some combination of that. So I'm gonna, in the next slide, show you a 1-minute video of DataChat. But before we go into that, that video is going to go fast. The field's moving fast. We're constantly changing our platform. And what you're going to see is a little bit rough, but that's what's going to ship in a month from now to our customers. And the key part of everything that we do, as Sharon mentioned and Blaine mentioned, is that what AI gives you is amazing and incredible, but you still have to have the means and mechanisms to trust it and to verify that you can trust it. And as you see, as the screen progresses to the video, what DataChat does is it's going to take, you can point your data to it, you can ask a question in arbitrary English, and it's going to give you an answer, but along with that, it's going to tell you the steps that it carried out, and you can pause it, you can make changes to it, and you can really start taking control. So we really think of DataChat as getting answers to anyone without having to learn programming in that sense. But it's really, the chat is between the human and the machine, but it's also between the machine and the human because it's a collaboration between both sides. So with that, if you could play that 1-minute video, and then I'll come back.
Ask is an AI-powered tool that can answer a wide variety of business-related questions. In DataChat, you can use Ask to pose free-form questions about your data and get a response that is both transparent and easy to verify. Here we have a database that includes tables about customers and their credit usage. We want to know how it may impact their ability to get a mortgage. We can ask DataChat what customer behaviors impact approved loan amounts, and let Ask work out the steps needed to answer the question. Ask then runs the steps to allow you to see exactly what it's doing. This is done transparently, so you can see both the end result and the steps that were taken to get there. This built-in transparency is a crucial part of our design. You are then given the answer, whether that's a new table, a visualization, or both. You can simply review the answer and iterate your question, or you can correct any misunderstandings directly in the suggested steps. For example, in this case, we can go back one step and examine the intermediate list of our customers. When appropriate, DataChat uses machine learning to detect and visualize the trends it discovered, enhancing not only your data discovery, but your data communication as well. As you keep working, the platform learns from your feedback as you upvote or downvote its suggestions. The more you use DataChat, the better it gets at answering your questions.
And of course, there's a team of 40 developers, most of them Badgers from here. We are headquartered in Madison, and we have tremendous advisors at DataChat, including Sharon. So we have an amazing team. So a lot of cutting edge work happening at the intersection of data, AI, and computing here in Madison. I'm going to end with this last slide over here, and then we'll go into a discussion. Literally a few hours ago, earlier in the afternoon, the next version of GPT was released. And this is a chart that shows how good is this new version of GPT, which is literally hours old now, is at taking exams. And they made it take a whole bunch of standard exams. The previous version of GPT also did that. But the improvements in just half a generation, the previous generation was 3.5, this is 4. That was just a few months ago. In just a few months, the bar exam is what lawyers take. It scores in the 90th percentile. And you can see the rest of the list, SAT, GRE, stuff like that. Everything in red over there, the AI is answering questions at the highest level of human capacity right now. Now, you could ask whether, to some of the questions that are being asked, you could ask whether those exams were testing anything, or is it something else that's going on? And we'll probably have a discussion on that. Notice, interestingly, the things at the bottom, AP Calculus BC, which is a high school level calculus, it can do quite well. And those of you who remember from your algebra to calculus stuff, there's a big switch as you go from algebra to calculus. It's a different way of thinking. It's not necessarily that linear path, very scripted path. And you could call calculus as being more creative. In fact, a lot of what AI uses as the math to make its algorithm work is calculus-based. But it can't do calculus as well. It can do simple algebra quite well. English, if you look at the GRE verbal, it can do that well. GRE writing can do okay. But AP English literature and comprehension, which is a lot more technical, right? That's where the art of English comes into play, very poor. Code Force, which is looking at developing non-trivial code, like the deeper algorithmic code, it does very poorly. So you can start to see the AI is amazing, but there are still things which we would think of highly creative, highly deeply logical thinking, and things in which you require artistic way of thinking about even math problems, for example, those the humans are still a lot better at. Whether that changes down in the future or not, we can discuss next. So thank you, everyone. Tom, back to you. Tom, you're on mute. Tom, you're on mute.
Sorry about that.
Now we know we have a complete meeting because we have to have this protocol.
Yes, we do. I should know better than that. Anyway, Your last slide showed that 90% score on the bar exam for ChatGPT. Sorry, yes, for ChatGPT, and then a very low score on coding. And so my question is, does that mean that lawyers are artificially intelligent, and that's why ChatGPT does so well?
It's a very interesting question. I have other analogy for this is radiology has been predicted to be the first deep medical science stuff which will be taken over by AI. And I asked my brother, he's not a radiologist, and my wife, who's also a physician, and they said, you guys are completely missing the point. The system needs someone to sue, and it's probably not going to be a bot. There might be a lot of that related to the lawyers too, which is where there's, of course, a whole bunch of rote rules that you have to understand to do that. But there's a lot of art in terms of how you present that in the court with the evidence at hand. So I don't think lawyers are at risk. It just probably means that the test taking that we do in many of these exams basically aren't testing anything. That's my take, but Blaine and Sharon have other views.
That's fascinating. I look forward to how that comes up. I might add, because there might be some people wondering what's going to happen to jobs. And there's a famous quote that was in the New York Times that we tend to use, and our chair of computer sciences, Ramsey Arpachi-Dussault, talks about it a lot, which is, it's not that machines will replace humans. It's that humans who use machines will replace humans who don't. Yeah. And that was the thinking. So with that, we have our first questions that come around the source of the training for artificial intelligence. So who decides, this is from our distinguished leader here, Mike Knetter, who decides what the source is going to be for training? And does that potentially introduce bias from what the selection is? Anybody like to take that question?
I'd be happy to take on that question. I'm actually really glad that the audience is raising that question around how do we regulate the training data, right, for this large language models, for example, and how do we? I also see that Kristen also raises a related question: is how do we maintain the equity of large language models if just a few organizations, companies are in fact creating them? I think to address that, one of the top priorities for the society and research community is to truly invest in these open science, in particular open large language models. So if we look at the landscape of existing large language models, the state-of-the-art conversational AI has been largely owned by a few proprietary companies. And they have the resources, like Jignesh mentioned, to train these gigantic AI models that takes gazillions amount of resources. And for example, OpenAI is funded largely by Microsoft, and other major tech companies are racing to release similar products and models. And so there's sort of, I think, a near monopoly status, if we could use that word to summarize the current, the language model landscape. And this raises a lot of ethical concerns. And so I think one of the most immediate issue for the research community is the lack of transparency. This is also something that's touched upon by Blaine, and in particular, these underlying training data sets. And in fact, the model parameters are not publicly available, right? The latest
Sharon, maybe can I interject?
Go ahead.
I agree. I think that the big models, GPT 3.5, I think took about 12 million to train, that is estimated. But that was the final training run, which is the final time you got the whole architecture in and you send that. They probably spent 100 million before that to try to figure out what to run. Totally agree with Sharon that there is that, Tom, to the question that you asked, what data does it feed in? Most of it is the data that we have all contributed on the internet. And I think the most direct version of this is we're all very excited about the large language models. But before the large language models all took off were all the image models with this big thing called Stable Diffusion. It just didn't catch the cultural zeitgeist, but you could actually ask it something in an English sentence to generate a picture and it would. But there, the issue that becomes right up front is that of copyrights. And you can have it generate an art piece that looks very much like an artist, a boutique artist who is making all of her or his living just of that, and now they've been taken. So now there's this huge legal argument. So lawyers are not going to be gone, connecting back to that earlier point, as to all this data is stuff that we've contributed by putting on the internet. And kind of when you do that, you give up that copyright, but do you really give it to someone who can then use it to spit things out? These models are memorizing and then pattern matching. They're creating new patterns for sure, but they're memorizing of patterns that have been fed to them. And to Sharon's point, the monopolists, I totally agree that there are a few of them, but you also have to give them credit, especially Google, because some of the breakthrough algorithms that happened and changed the world that we are in right now happened because they came up with those ideas and they open source it to everyone. And it's a little ironic that Google had something that was potentially as good as ChatGPT about a year ago, but didn't make it available to the world because they had different calculations going on there. But we should also thank these big industries for really moving the field forward. Sharon and Blaine's point are absolutely correct. That means, if we really want this to continue, there must be access to that type of innovation in academia for this to continue. So, there's lots of complicated issues. The last legal issue is the imaging part, where the legal issues become very apparent because you can see the image and say, this looks like something that I owned or I created. It's hard to do that with 20 or even 20 pages of text, super hard, not impossible. But the way many of those models were trained on the imaging case was these companies knew there was potentially a legal case. So they created shell companies where all the data all the images from the internet was scrounged and licensed back to these model companies. So effectively, lawyers are always going to be needed. All kinds of little plays, and us as a society have to go and figure out, how do we compensate people? How do we not violate people's copyrights? Because these model strains of data that humans have created, at least as of now. And so that's kind of where that question stands. And Blaine and Sharon, you may have additional things to add.
Yeah, I
Absolutely.
totally.
I think you bring up oh, sorry, you go ahead.
Go ahead, Blaine.
Okay. Yeah, I think you bring up a lot of great points. And going back to kind of the inequity thing, I think that there's also a question as to whether these models really need to be as large as they are. I mean, GPT-4, I think, is hundreds of billions of parameters, and we only have 85 billion neurons in our brains, and that accounts for everything from image recognition to speech to motor control to everything, the way that we process language. So it kind of makes you wonder why we need these language models to be as large as they are. Maybe our brains have a more succinct way of representing this information. And I think that making them as large as they are is also causing a lot of inequity. So maybe a way to balance that would be to kind of look towards biological inspiration for that.
Well, that's terrific. We're going to move on. By the way, listening to this reminds me of something that the famous MIT professor Noam Chomsky said. He thinks of ChatGPT as tech plagiarism. So that's his perspective. So we're wondering, and Sarah Shute gave us this question, what are some real life examples? Blaine, you started to talk a little bit about some of those. You want to follow on and talk about where you see real life examples, and then the others can chime in?
Yeah, absolutely. So I know there was a part of the question was that examples where the average consumer may not be aware of. I think one of the areas that people usually aren't aware of AI being present is recommender systems. When you log into Netflix and you get the For You page or Hulu or anything like that, there's an AI system on the back end that's making those decisions. And not even just choosing the movies and TV shows for you, but there's actually different subsets of images that they're going to display to you when advertising this movie or show. And so they decide which of those images you're going to respond best to based on this AI system, which I think is really interesting.
Cool. Sharon, Jignesh, anything you'd like to add?
No, I think that was a great answer. I do have a question for Sharon at some point.
Go for it, Jignesh. Go ahead.
Okay, I think very much related to that inequality point, and I'd written this down a little before. The bigger thing that is scary to me as a faculty member is the industry is very rich right now, and AI is making them richer. And it's not just they can produce these models, but they can take faculty like Sharon and pay her 5 or 10 times as much as we are paying. And that's happening in many universities. So, a bigger issue I worry about is how do we keep these stars like Sharon and Blaine and keep them in academia, because someone's got to teach that next generation of students. So, and that is a bigger issue, right? I'm not so worried about that it took 12 million to build a model, because just 10 years ago that was impossible to build, and just 3 years ago it was a lot more than 12 million that was not revealed. And from a lot of the algorithmic innovations that are happening, and it's that data, you can feed more data and you can make these things work faster. You don't have to necessarily have more parameters all the time. There are some really nice results coming out on that. So you can feed it more data and you can get by with smaller parameters, to Blaine's point, that you can have smaller models. That's probably what we humans do, right? We take in a lot more data than what these models are taking in. So I think we will keep continuing the innovations, but that will happen if we have people like Blaine and Sharon be in academia, and academia doesn't pay anywhere close to where industry pays people who know this game. The last point on that is even though Google and its branch OpenAI and DeepMind in Europe innovated some of the big things that came out recently, with ChatGPT, with GPT-4, the paper just came out earlier this afternoon, and you can already start to see the industry starting to shut down. They're starting to take, here are the big ideas that we did to create these models, and now they're not revealing as much. So the question to Sharon is, I hope she stays forever with us and teaches the students, and I would love to get her comment on, is she concerned that industry is going to start sharing some of the secrets for what algorithms are working for them behind their walls?
Thank you, Jignesh. I really love the points you're raising. And in fact, this goes back to one of the early points that I was trying to make is, I think to counteract some of these issues concerning this widening gap between academia versus industry, it's more than urgent for us to really start investing in this open large language models, right? And so, for example, non-commercial organizations such as universities typically lack the computing and financial resources, right, to keep up with the race, especially this fast evolving evolution of large language models. And so I think it's very important for the scientific funding organization, university, non-government organization, NGOs to make considerable investment in this nonprofit projects and start building for that open source environment that everybody gets to contribute. And hopefully this would also lead to or alleviate some of the barriers for researchers to look at some of these underlying issues involved in biases, transparencies that existed in these large language models. And so I think all of this could potentially help resolve some of these issues around democratically controlled AI systems.
Yeah,
so that's
and to Blaine and Sharon, I would say you can always be in academia and do a startup, and Wisconsin is wonderful at supporting both of that. So awesome. Thank you to Wisconsin for doing that. So don't leave academia.
We're going to move into the fast question answer part of the session because we only have a few minutes left and we have lots of questions. So a number of things here about ChatGPT. One about the elections in ChatGPT. Does anybody see a role that ChatGPT might play in the elections?
The quick answer to that is absolutely yes. It will be far easier to generate fake news stories that sound less and less fake. And so in many ways, humans will have to become more smarter about having higher human cognition. We're going to have to live in a world that's messier, and it's harder to distinguish what is real and what's not. You just have to be more informed.
The next question was about, do ChatGPT and other platforms play a role in actually the curriculum or education at UW-Madison? And do we have a policy? I don't know if any of you are up to speed on that. If you want to weigh in or, or not. I have a comment if not. So
I can take a really quick crack at it. As far as I know, we don't have a formal policy, but you can already start to see professors starting to do things like saying, you can't tell students not to use ChatGPT and other tools like that, but you can, it's like that test taking. Can we make test taking not be about regurgitating something, but about assimilating and showing that work? Multiple ways to do it. You could have exams in person. If it's a writing exam to test creativity, it can be in person rather than remotely. And for other technical subjects, you can completely change the exam so that it is not by rote.
Okay, one of the big things that's come up, people feeling this all sounds very dangerous. One of the questions is, what if the learning models are really bad? Or what if there's just a lot of bias? Or what if we build systems that use this stuff? So this is dangerous. Blaine, this is an area you're talking, you're spending a lot of time. This sounds scary.
Yeah, absolutely. I think that kind of going back to one of the points that I made in my presentation, this is why we need policymakers. This is why we need rules and regulations and robust tests to figure out where these vulnerabilities are before models like this actually get released and could cause public harm.
Mm-hmm. That's great. We have one more here that I'd like to do. If someone wants to learn, a couple more, if someone wants to learn how to code or how to write, input for ChatGPT, what's the best way to do that?
I don't have a good answer. It's trial and error. I don't know if someone has a better answer. But probably the answer is you will have to worry less and less about it, because the newer and newer models are getting better and better at sort of understanding you without you having to work too hard at it. But they're very sensitive right now, for sure. Yeah,
I do agree with you. I think it's trial and error. See if you like the result or not. Mind you, the results are not long, so you can peruse your results quite easily. A really interesting question from Steve Goldstein. What options might exist for a different interface? One other thing we study, we're not talking about it tonight, but is what's called HCI, the Human Computer Interface. And we have a lab just dedicated to that in our new building, which I might put in a plug for right behind me. You can see the models for that. Construction started last week. We have a HCI lab on the 4th floor. Do we have new models that will be better than our current models, that will be sort of more intelligent? Are those on the horizon? Anybody? Well, I have some ideas.
I think, yeah, maybe a really quick answer to that is the ChatGPT algorithm and models like that, potentially superior, existed like a year ago. As I just mentioned, Google had that. But they couldn't figure out how to really make it work. They put pieces of it to work in Google search, mostly around better understanding preposition when it shows up in your Google search. But the key innovation, if you want to think about why ChatGPT caught on fire, is because they put a chat interface on it. And there was a little bit more they did algorithmically to take the text that you type in over there and to understand which part of the GPT brain to tickle. For the technicians, it's the RLHF loop that they put in there. But kept the interface really simple and basically said you can ask it anything. That broadened the scope, simplest interface that anyone on the planet could use. And that's exactly what Google did when they were a small search company. If you remember back in the days when Google wasn't the king of the search, in late 90s, even at the turn of the century, it took them a while to say the simple stuff is just have a screen and a search bar and let people ask and you find them the answer. That was the big UX innovation in ChatGPT, not as much as the algorithms and stuff behind it. And so the answer is yes. What is that? Don't know, but there's going to be a ton of human creativity, and very likely a ChatGPT is not going to find that answer.
Yeah,
I totally agree. I think we're going to see. Oh, go ahead.
Oh, go ahead.
Yeah, I totally agree. I think that we're going to see really new, interesting ways that humans end up teaming up with AI systems. and interfacing in new ways beyond just a chat box.
So I have one final question for each of you. Quick answer, which is, is there someone people should follow or a book they should read if they want to learn more? Sharon, we'll start with you.
I would recommend a researcher who has really done a lot of wonderful works around understanding these foundation models, such as large language models, called Percy Leung. And recently his group actually released a pretty cool open source demo called Alpaca, which is kind of intends to showcase the ability that's equivalent to GPT 3.5. Which is the precursor of ChatGPT. I think he has a very active Twitter thread that's worth following up on.
Can you repeat his name again?
Percy Leung. I would type in the thread so we can share with the audience.
Blaine, over to you. Who would you recommend, or what would you recommend?
Well, I think if you're interested in reading some more articles about the latest and greatest AI systems and also some of the failure modes too, I think that the Stanford HAI Twitter page posts a lot of really good articles. Also, another UW alum, Sebastian Roschka, I think is how you pronounce his last name, posts a lot of really, really great, informative, a little bit more on the technical side, ML knowledge.
Over to you, Jignesh.
Yeah, I think I follow a lot of people on Twitter. The ML stuff, AI stuff is happening over there. I really like one of the three founding fathers, Yann LeCun, because he's very active on Twitter. Though a lot of the core work was done by Jeffrey Hinton from Canada. So if you had to follow one who's very active and you can see what's going on, that'd be Yann LeCun on Twitter.
Can you put his name into the chat so we can get the spell
Yep.
out? So thank you all panelists for a very, very special evening. I'm so grateful that I get a chance to work with all of you. And as we move forward in this very exciting yet very scary domain. So thank you, everyone. Appreciate it. And thank you, audience, for joining us. It's been exciting. I'm very grateful to be the first guest host. I hope that I haven't spoiled the show, Mike, and we get a chance to do this again. So
I am sure we will. This was terrific. Thank you for doing this, Tom. And I really want to thank our three guests, Sharon, Blaine, and Jignesh. They did a great job. And I encourage viewers, if you haven't tried some version of this ChatGPT artificial intelligence app, I would go download one. I've had a lot of fun asking it to write a strategic plan for my organization, asking it why someone would want to live in Wisconsin. It's amazing how quickly it comes back with really pretty, often very sensible answers. Good news for sports talk radio people. I asked ChatGPT just now, why would the Packers trade Aaron Rodgers? And what I learned was the reasons behind the potential trade of Aaron Rodgers could be ambiguous and based on several factors, such as the team's management, coaching staff, players' performance, behavior, and salary cap issues. It's also possible it could be due to conflicts or disagreements between the team and the player. In other words, not very intuitive. So sports talk radio seems safe from ChatGPT. I don't know about the rest of us. It's possible you could run the foundation with ChatGPT better than I'm doing. I don't know. Let's hope not. But seriously, thanks for joining us tonight. This is a really exciting area, and I think we should all be paying attention to it. It's also a little bit scary. Who is behind it? Who's deciding what the information sources are that these apps use? That's going to be a big issue, I'm sure. But really appreciate having experts come on and give us their take on it. So we'll be back again. We don't yet know when, but it'll probably be a couple weeks from now. Just watch our UW Now weekly output, and we'll let you know what our next topic is. But thank you all for joining us, and on Wisconsin.
It's subtle, the way things are changing. The scenes once imagined decades ago now show up in our daily lives. It's here, the future, and none of us can expect to face it alone. Alone isn't where ideas thrive. That's why UW-Madison created the School of Computer, Data, and Information Sciences, connecting ideas, connecting data, connecting people who will work at the intersection of technology and humanity to solve society's greatest challenges. UW-Madison will be where the now and the next converge. It's a first-of-its-kind collaboration in the nation, lighting the way forward for research and discovery across campus. A cutting-edge building where the best and brightest will be drawn to collaborate, completing a tech corridor at the center of campus, magnifying the power of medicine, engineering, agriculture, and business, an economic engine for the state, where ideas converge to form a foundation for the future of science and industry. It's the Wisconsin Idea 2.0. Not only will the influence of the university work to the benefit of the people of the state, but this new collaboration will make every idea better. When we connect, the future begins. CDIS, the convergence of what's next.